All right, first things first, if you didn't watch the Intro to Energy video that Mrs. Rona made, you have to go back and watch that now because that has a bunch of really important notes on it. So if you haven't done that, you have to do that first. All right, second, one of the big things from the video is like what is energy, right? And energy, if something has energy, it has the ability to cause change. I like to make it a little bit more exciting and say, if something has energy, it can break things, it can damage things, it can destroy something. So that's a kind of an easy way to remember how we define energy in sort of an operational sense. So if something has energy, it can cause damage. Just kind of think about that. The more energy it has, the more damage it can cause. So we have a rubber band. Well, this isn't a rubber band, it's a little hair tie, but you have your rubber band in your little physics take-home kit, or go get a hair tie, or go get a rubber band, or whatever. So go find something that is stretchy like this. Pause the video and come back. I'll wait. All right. With this little rubber band or this hair tie, I can cause some damage. Well, what can I do? Well, I can pull it back and shoot it at you, except you're probably not scared because it's just through the video. Or if you put it over your hand like this, and then you pull back, and then you can hit your hand, right? So there we go. And now one thing you'll notice here, if I pull back a little bit and try this, okay, pull back a little bit more, hurts a little bit more, pull back a little bit, hurts a little bit more, really pull back, and it really hurts. So it must have more energy when it's pulled back further because it hurts more, causes more damage, right? So there's a relationship between the stretch, how much this is stretched, and how much damage it can cause. So therefore there's a relationship between how much it's stretched and how much energy it has. And that's what you're going to investigate today during class. So you'll need to go to the lab slides for your class, so 2nd, 4th, or 7th period. And then there's a link to the simulations right here. And this is what the simulation looked like. Hit the begin button. So you will be assigned a different spring number based on your group. So group 1 has number 1, group 2 is number 2, group 3, group 4. If you're group 8, sorry, you just get to choose a random one. Don't tell anybody though. And you'll notice the spring changes a little bit. We'll talk about that later. And it says, before you do anything else, record the original length of your spring and the spring number you are using for this lab. So the original length of the spring on this one on my screen, you'll have to do it for yours, is, let's see, 11, 12, looks like about, it goes out to 13, but it starts at 1, 2, 3, so it looks like it's about 10 centimeters. What I have here is a force probe, and then it's going to exert a force on the spring. So basically we're going, so a spring is very similar to a rubber band. Energy stored elastically is what we're looking at. I know we talked about this having energy, but it's energy stored elastically. And so what we're going to do is we're going to stretch it out. And you'll notice when you do this, if you have your rubber band and stretch it out more and more and more, it gets harder and harder and harder and harder. So that's what we're going to do. You will hit start, and it stretches it out. You can see the force here. And then, if you scroll down here, this is really easy. Your graph is already done for you. So the force versus stretch graph. Usually in the classroom, what we would do is you'd stretch it some, you'd record the force. Stretch it more, record the force. Stretch it more, record the force. But the graph is already done for you here. So then you're going to screenshot that graph and bring it back over here. So group 1, you're going to put yours here. You're going to write your physics equation. Now, a few things to remember with your physics equation. The rules are you need to use physics variables and not x and y. So don't use y for this variable here. Use a letter that represents force for a spring. Here, use a letter that represents stretch. Maybe because it's the stretch from like this point or where it started to here, it's like a displacement and it's horizontal. So let's use this one instead of S or whatever. We're going to use delta x for this. Okay, so use delta x for stretch. And then with your physics equation, your slope, whatever your slope is, you got to have the right units. Remember, units of the slope are units of the y-axis over the units of the x-axis, and you're going to have to figure out the slope based on this graph. So you're going to have to figure out some points that are on this graph and figure out what the slope is there. You don't have to do anything in pivot. Nothing is done in pivot. And then I want you to calculate the area bound by the curve. So we have our little triangle here. find that area. Okay, so graph, physics equation, and then area. Make sure you have units with every number and make sure you're using appropriate variables. Then with your group, you're going to do these analysis questions. What are the units of your slope? Put your slope in sentence form, so it's like a for every statement. So for example, if my slope is 4 meters per second on a position versus time graph, it's not going to be here on meters per second for this, so don't use that. I would say, for every second that passes, I travel 4 meters. Okay, so think about that, like for every one whatever, what happens? How much does something else change? Number 3, what do you think determines the different values of the slopes? Then you're going to need to go and look at other groups. Look at other groups. What did they do? Why is their graph differently? What was different about their lab procedure? What are the units of the area, and what do you think your area means? All right. So the expectation is you and your group have all of this done by the end of the period today. All right. And that is it. I will see you tomorrow.